Hello. In this lecture, we will start with the apparent depth of a liquid. As you know, one of the consequences of refraction from denser to rarer medium is that the depth of a pond appears to be less than the actual value. Let us now establish the relationship between the real depth and the apparent depth of a liquid. Let it is a beaker which is filled with water. Refractive index of the water is taken as mu B and the refractive index of the air is mu A. O is an object lying at the base of the beaker. The ray is going out from the object from denser to the rarer medium, so it bends at this point away from the normal. The second ray is going normally. As it is normal, angle of incidence is 0, so it goes undeviated. For an observer standing outside, that is in a rarer medium, for that observer, the ray of light is coming from the point O dash. So for the observer, the depth is HA. So it is called apparent depth, the depth which appears to the observer, but the actual depth is HR. Now we are going to derive the relationship between HA and HR. Now, as the ray of light is going from denser medium to rarer medium, so the angle of incidence is I and this is the angle of refraction. As you know, A mu B is equal to 1 upon B mu A. So, A mu B equals to sine R upon sine I. From this diagram, as this is the angle of incidence, so it is also I. This is R, so this angle is R. Now from this triangle, sine I equals to perpendicular. Say this point is A, this point is B. A, B upon hypotenuse BO. And from this triangle, sine R equals to AB upon OB. Now put the value of sine AI and sine R. It becomes AB upon OB upon AB upon O dash B. That is equal to O dash B upon OB. O dash B, is approximately equal to O dash A as the angle of incidence and R is very small. And OB is taken as OA. So O dash A is equal to HA and OA is equal to HR. HA, that is the apparent depth, and HR, that is real depth. It is B mu A. So A mu B is equal to OA upon O dash A, that is equal to the real depth upon apparent depth. Is it clear? I think you are able to understand this derivation. It's clear to you? Now, apparent shift, that is this one. This is called apparent shift, which is equal to O dash is the apparent shift, and this O dash is equal to HR minus HA. From this expression, HA is equal to HR upon mu. Taking the HR common, apparent shift is equal to the real depth to 1 minus 1 upon mu is a apparent shift. Now, if the observer is in rarer medium and the object is in denser medium, means to a bird, the fish appears to be nearer than its actual depth. Or if the observer is in denser medium, that is for a fish, the bird appears to be farther than its actual height. Now the next topic is total internal reflection. Let O is an object lying in a denser medium and the rays are going out from this object. As this ray is going normal, it incident normally, so it goes undeviated. Now this ray is incident at an angle I1 and the angle of refraction is say R1. Now the second ray, at this ray it is incident at an angle of incidence I2. As the angle of incidence increases, angle of refraction also increases. Now, angle of incidence increases further, and say for this angle of incidence, angle of refraction is 90 degrees. When we increase the further angle of incidence, now this angle is greater than IC. And for this angle of incidence, angle of refraction also increases and is reflected back in the same medium. And this phenomena in which the ray is reflected back within the same medium for the angle of incidence greater than the critical angle, this phenomena is called total internal reflection. The conditions necessary for the total internal reflection, that the object must be in denser medium. That is, the ray of light is going from denser medium to rarer medium. Second, the angle of incidence must be greater than the critical angle for the medium. The critical angle is the angle of incidence at which the angle of refraction is 90 degree. Critical angle is the angle of incidence for which the angle of refraction is 90 degree. Now derive the relationship between the critical angle and refractive index. As you have seen that the ray of light is going from denser medium to the rarer medium. So sin I upon sin R, angle of incidence is critical angle, then the angle of refraction is 90 degree. So G mu is equal to sin AC. You know the relation that A mu B equals to 1 upon B mu A. So A mu G is equal to this. Hence A mu G is equal to 1 upon sin C. And you know very well that mu is refractive index is inversely proportional to the wavelength. So we can say that the red color has maximum value of the critical angle and the violet color has minimum value of the critical angle. Thank you and have a